Hey, good people, this is Arthur Morris. I hope that all is going well with you today. In this video, we are going to look at graphing linear inequalities in two variables. Graphing linear inequalities in two variables. So, the first thing we want to do, we want to uh, find our points for our line the same way as we find the points for any line. Maybe get it in slope-intercept form, y equals mx plus b. Plot your y-intercept, use your slope to draw the line. So that part does not change. What does change is if you use a solid line or a dashed line. Now, if you have the or equal to bar underneath your inequality, then you use a solid line because we're including those points on that line. If we do not have the or equal to bar, then we will use a dashed line. And then also with inequalities, we have several solutions. So we either have solutions on the bottom or underneath the line or above the line. A couple of ways we can find out where those solutions are. One, if it's less than, then it's underneath the line or to the left. If it's greater than, then it's above the line. The other way that you can find out where your solutions lie is by using a test point. So you can test a point in on either side of the line. Take that point, that ordered pair, plug it into your inequality. If it makes a true statement when you plug it into your inequality, then every other point on that side of the line where your test point is a solution for that inequality. And we shade on that side. If it does not make a true statement, otherwise if it's a false statement, then we shade on the opposite side of the line of that test point. Okay, so let's look at graphing this inequality. So we have 6x minus y is greater than 12. So what I want to do is to solve this inequality for y. So subtract 6x from each side. And then divide both sides by -1 or multiply both sides by -1, either way. Remember, when we divide both sides of an inequality by a negative number, we have to reverse the inequality symbol. So we have y is less than 6x minus 12. So that tells me when I shade, I will be shading underneath the line. But first of all, let's find some points. So I'm going to use my slope and my y-intercept. So my y-intercept is -12 or the point 0, -12. And my slope for graphing purposes is the number being multiplied by x, or 6 over 1. So plot my y-intercept first, and then use my slope. Rise 6, run to the right one place. And I'll get a few points here. All right, now, since we did not have the or equal to bar underneath our inequality, we need a dashed line. So the line will not be solid. We also have to shade on one side of the line or the other. Now, to find out where we shade, you can use the idea of, since this says where I solved for y, since that says y is less than, then I would shade below the line. This line is tilted up and to the right, so below would be on the right side there. The other idea is to use a test point. And the easiest test point to use is 0, 0. As long as your graph does not go through the point 0, 0. So if I test 0, 0 back into my original inequality, and then simplify it. 6 times 0 is 0, and 0 minus 0 is 0, I end up with the inequality of 0 is greater than 12, which is not true. Therefore, my solutions will be on the opposite side of the line of that test point. So 0, 0 is on the left side of the line. So since that's not true when I tested it, then my solutions will be on the right side of the line. So I must shade on this side. So that tells me that any point in that shaded area on the right side of that line makes a true statement for that inequality, or it's a solution. Okay, let's try another one. All right, so here we want to graph y is less than or equal to 3x minus 4. All right, so we can go ahead and identify our y-intercept. 0, negative 4. And then slope is 3, or 3 over 1 for graphing purposes. So y-intercept, I will plot that first at 0, negative 4. And then slope, from there, go up 3 places and to the right 1 place. Okay, now in this inequality, we had y is less than or equal to. So since I have the or equal to bar, I will use a solid line. And then I still must shade. So it says less than. So again, I'm going to have to shade below the line here. And we can test 0, 0 just to make sure that I shaded in the correct place. So replace x and y with 0. 3 times 0 is 0. Minus 4 is negative 4. 0 is not less than negative 4. So that means that I must shade on the opposite side of the line from where 0, 0 is, which means all of the ordered pairs on the right side of the line or below the line are solutions for that inequality. Now what if you have a vertical line or a horizontal line? Here we have the graph x is less than or equal to negative 2. And we know if we don't have the y variable in a linear equation like this, or inequality, then that creates a vertical line crossing the x-axis at negative 2. All right, I see that I do have the or equal to. So since I have the or equal to, that means I have a solid line. And it says x is less than negative 2. So since that's a vertical line, then I either shade to the right or to the left. Well, we know if we go to the right, then that's greater than. So to the left would be less than. Can you still use a test point? Sure. So uh, again, the easiest test point to use if your line does not go through that point, or your graph doesn't go through the point, is 0, 0. In this case, I expect it to make a false statement. So x is 0, so if I replace the x with 0, x is not less than or equal to negative 2. Therefore, that's not a true statement. Therefore, I should shade on the opposite sign of where 0, 0 is. Okay, what about y is greater than 1? Well, y is greater than 1. That will give me a horizontal line if I don't have the x variable in that linear equation or inequality, crossing the y-axis at 1. Now, I don't have my or equal to bar, so I need a dashed line. And it says y is greater than. Well, it has to be above or below. So greater than would be above. All right. You can test 0, 0, and you see that it would make a false statement. Therefore, we should shade above the line and not where 0, 0 is located. All righty, good people. I hope you found that video to be helpful. I will see you on the next one. Thank you.